Live! Hey, how are you? Welcome to lesson 22, crossover points. As I usually say, down in the description of the video description down there, especially if you hit the show more link, you will get an opportunity to download the PDF file of what you're looking at right here. This is what you're looking at right here, right? And also the homework set that goes with this. So, enough said, enough said. So crossover points, what's going on here? Well, we're playing with straight lines. We're going to sort of extend our knowledge of straight lines a little bit here by playing with straight lines. And this is a particular application that you see a lot of this, or at least I did. I went through Alex. You know, I did the whole Alex thing myself. I pretended I knew nothing, and I did the whole thing, and it took a while. But I did it, and I noticed that they had a lot of these kinds of problems. So I thought, you know, it's probably worth looking at. And besides that, it is a sort of a fairly common, should I want to call it a business situation or something? Not just business, but business is a prime example of this kind of analysis. So let's do this analysis. What am I talking about? I'm talking about like comparing two things. Biff right now is paying $200 per month for electricity. Okay, because he's hitched up to the power grid, whatever. He's paying $200 a month. But maybe he should get solar panels. Now you'd have to pay $9,000, which is kind of a lot. But when you pay for the solar panels, well, you pay less every month for electricity, $50 instead of $200. So it's a lot of money up front, but is it worth it? Well, you could, I suppose, if you want to just do plain arithmetic, and sometimes that's a good starting point, plain arithmetic, you could ask yourself, look, I got to spend $9,000. How long is it going to take me to get back my $9,000? Well, I'm going to be saving how much? I'm going to be saving $200 a month is going to be only $50. So instead of paying $200 a month, I'll pay $50. So I'm saving $150 a month. So I could just kind of say, well, I'm saving $150 a month. How many months is it going to take to get my $9,000 back? So you take your $9,000, you divide by 150, and you know what? I'm going to do this down here because you'll see part D. This is the actual question here. What is the payback period? So we can do it arithmetically. I'll do this in a fancier way later. But the arithmetic approach would be to say, look, I got $9,000 I want to spend. If I do spend it, I'll save $150 every month. And if you divide 9,000 by 150, that comes out to 60. So it's going to take you 60 months to get your money back. Are you sold 60 months? That sounds like kind of a long time. As an alternate, I just want to throw this calculation down because you're going to like it later. I'm going to show this. You could say, well, you know, it's going to be $9,000, and think about a year instead of a month. I'm saving $150 a month. So times 12 months, 12 times 150 is, I want to say 1,800. Yeah, I'm pretty sure. 1,800. So if you take 9,000 and you divide by 1,800, now you're talking about years. You're spending 1,800 per year. So 9,000 divided by 1,800 means it's going to take you 5 years to get your money back. Now I suppose, of course, you could have also done this. You could have said, hey, 60 months is 5 years, right? Divide by 12. But I wanted to show you this 1,800 number. Anyway, it's going to take 5 years. Now, here's the problem. That's just some number sitting there. Hey, it's going to take 5 years. But what you really want to do sometimes, maybe if you're the guy that's thinking about buying the solar panels, you want to do this. But especially if you're the guy selling the solar panels, you're going to want to do this. You're going to want to have a visual that shows, that really brings it home. How much am I really going to save? You know, I just say something like, hey, pays herself in 5 years. That doesn't, are you impressed? I'm not impressed by that. That doesn't impress me. I'm like, what? You want me to spend $9,000? What are you talking about? But watch what the graph looks like. Okay, we're going to build a graph and you're going to be impressed. So, okay, what does it say here? Let's follow the steps now of our solution. It says, write an equation for dollars spent on electricity without solar panels. Okay. So remember, we have, well, $200 a month. Now they're saying years, right? So actually times 12. $2,400 a year Now, when you say $2,400 every year, and you think back to the previous lesson, and you say that's a certain that $2,400, I go up $2,400 every year, up $2,400 over a year, up $2,400 over a year. Doesn't that make you think of a slope? Symbol M. And then starting at what? Well, starting at nothing. I'm already getting electricity, right? Start at 0, really. And what you start at is your B. And so, you know, this is basically a straight line kind of a situation because we have a fixed amount every year. We start at 0 and we add $2,400 every year. That is a perfect example of a straight line equation. And so if X is going to be years, then I'm going to have to pay 2,400X plus nothing. This is an equation for the dollars spent on electricity versus years without solar panels. Now, let's do the same thing, but we'll write an equation using solar panels. Using solar panels. Well, how much am I paying a month? I'm paying $50 a month. That's nice. Now, we're talking about years here, so that would be 50 times 12, you get $600 a year. And that's the, you know, what we used to call variable cost. It's like every time a year goes by, it's another $600. Another year, another 600. 600 up 600 over a year, up 600 over a year. This is telling you the slope of the cost line. And then we're starting at, well, you have to buy your solar panels. So in order to, you know, only spend 600 a year, you have to start at spending $9,000. So that's your B. And so what does the equation look like? With solar panels, your cost will be $600 every year. So $600 times the number of years. And then add the 9,000 on because you had to start by spending 9,000 out of your pocket right away. So look how quickly we put together two very nice formulas that we can plug X in and solve for Y for any number of years you want. And you can have your total cost. Now here's where we make money as advertisers. Sketch the graphs of these two equations. Sketch the graphs on a graph. Okay, that's what we'll do. We're going to sketch these graphs on a graph. So X is the number of years going by. So let's label, maybe I'll do something like this. I'll try to make this show up a little bit and say that's my X-axis and X is years. So I'll say X years going that way. And then this will be the cost, of course, going up on the Y-axis. So it's sort of darkening the Y-axis a little bit. And I'll call that Y, and maybe I'll just put a dollar sign. Okay, so years, we're going to have, by the way, we already figured out, right? We already know it's going to break even at 5 years. So let's do something like 1, 2, 3, 4, 5 years. We know we're going to break even at 5 years, 6, 7, 8, 9, 10. But what we want to do is we want to impress upon this potential customer. Did I do that right? 11, 12, 13. That's not where 15 is. Okay, that's where 15 is. We want to press upon this possible customer like this is going to be an amazing thing for him. That's what we want to do. So, okay, let's start graphing. Oh, wait a minute, we should label this too. Now, it helps that I've already made the graph, so I know how to label this. So we're going to call this $2,000, that's 0. $4,000, in other words, we're going to count by twos. 2, 4, 6, 8, 10, this is $10,000. 12, 14, 16, 18, here we are, way the heck up at $20,000. Spending a lot on your electricity, folks. Now to graph this line, call it line A, y equals 2400x. The y-intercept is 0, means we start here, right? It's 2400x plus nothing. There is no y-intercept. The y-intercept is 0, actually. So, but the slope is going to be 2400. So every year is up $2,400. So 1 year, $2,400. So come out to 1 year, go up to $2,400, and you have to kind of estimate it somewhere around there. If you come out to 2 years, you'd be at 2,400 plus 2,400, which would be 4,800. So you have to kind of estimate where, oops, over here. You have to kind of estimate where that is, somewhere around there. Come out to 3 years, you get 2,400 times 3 is 7,200. So there there's 6, there's 7, it's something like there. Come out to 4 years. 4 times 2400 is 9600, so we're like way the heck up here someplace. And then at 5 years, 5 times 2400 is, actually that's exactly 12,000, so that's here. And I like that. Notice when it lands on something even like this. It took me 5 years to get to a perfect 12,000. Use that fact to say, well, in another 5 years, I'll add another 12,000, and I'll be at 24,000. See? How's that for a nifty shortcut, huh? Every 5 years, it'll be up another 12,000. Anyway, we can sort of draw our line now, especially if we had a ruler. Look how perfect that is, huh? And so this is line A. This is without solar panels. Now let's do line B. 600x plus 9,000. So notice this line does have a y-intercept. We're going to start when x equals 0. We're going to start. By the way, notice you could literally plug in x equals 0 and find that y is equal to 9,000. It really is the y-intercept. So y-intercept of 9,000 means we're going to start at 9,000. There's 10,000. There's 9,000. We're starting right about there. Unfortunately, the slope isn't as much. The slope, in fact, is only 600 for every year. So 1 year we go up from 9,000 to 9,600. It's like we don't even reach the 10,000 mark yet. You go up another year, you're up another 600. Let's see, where were we? Well, 2 years is 1,200, so 9,000 plus 1,200 brings me up to 11,200. And oh heck, you know what? We know we're supposed to break even at 5 years. So I know I'm going through that point. So why don't I just do this? So I went from 9,000 to 12,000 in 5 years. So I'm going up 3,000 over 5 years. So if I go up another 3,000 over another 5 years, it's got to be going through that. Up another 3,000 over another 5 years, it's going to be going like that. And there's our line B. This is with solar panels. Now, look at what we're staring at in front of our faces right here. Are you not kind of impressed at the region out here? You know what you're saying when you're out here? You're saying, I'm happy that I bought my solar panels from that Fred guy or whatever. You're not happy right now, but 5 years will go by and it's like, yeah, I know, you told me 5 years I'd break even. But look at this widening gap. This is all savings up here, right? Savings, wow. And that makes a nice brochure, don't you think? You want to put that graph on the brochure. You don't, I mean, you're trying to sell this business owner, right? Wasn't it a business? Yeah, it was a business guy. You're trying to sell a business owner on something. It's not going to be good enough to put a picture of a puppy. He wants to see some kind of money thing, and so you show him this money thing, and you say, look, man, we're talking 10 years from now. Look how happy you'll be. You'll just be raking in the savings, and if you're going to keep your business for at least 15 years, you're going to be raking it in even more. You're going to be so happy. Get your solar panels, will you? Of course, the next question is, well, how long do they last? And I wish I knew the answer because I don't. But anyway, this is a really nice application of graphs. So I mean, it's y equals mx plus b. It's the same stuff we were playing with in the last lesson. Good old y equals mx plus b stuff. And yet, look at what a nice sales brochure you get out of it, right? Plus, it's a nice way to sort of visually go, how should I say this? You can see what's going on right away with your eyeballs, right? I remember reading some article somewhere that said the reason humans have such big brains is because they developed to support our vision. No, we can't see as good as an eagle, but we can do a lot with our eyeballs that eagles and other animals don't. We can look at this and go, wow, I'm saving a ton of money with our eyeballs. We can do that. It's cool. Visuals, I think, a picture's worth 1,000 years. Visuals are good. Now, I wanted to come back to this part D that says, what is the payback period? Because okay, we did already solve it, but I want to show you something kind of cool. Without solar, the cost was $2,400 per year. With solar, the cost was $600 per year with $9,000 up front. Let me make sure I got those equations right. 2,400x. Yeah, good. I got the equations right. So this is nifty. So Y dollars is what you'll spend without, and here's an equation for how much you'll spend Y with. And so what you can do is you can say, or you can ask, when, which means at what x, at what value of x, are these costs the same? Because looking back at the graph here, when the costs are the same, this is me spending for electricity without my solar. This is me spending for electricity with my solar. And you'll notice that here's the crossover point right there. That's where the costs are the same. And that's what defines your payback period of 5 years. And you go beyond 5 years and all of a sudden the solar is a much better deal. I suppose if you're only going to stay in your business for 2 years, you probably don't want to. But if you're planning to stay in this business for at least 10, 15 years, it's probably worth your while to get the solar. But anyway, where these costs are equal is the idea here. That's where you've found your payback period, the crossover point right there. And so that's why I'm down here asking, when or at what value of x are these costs the same? Well, if they're same, that means that the 2,400x, that's how much you paid without solar, will be the same as the 600x plus 9,000. That's how much you're paying with solar. And you got a beautiful little equation there that you can solve without too much trouble. Subtract the 600x on both sides, right? Get x by itself, or get all the x terms to the left. And what do we got here? 24 minus 6 is going to be an 1,800x here, is equal to a 9,000. And then this is the part I love. This is the part I love. I've always loved this about algebra. It knows what's going on. It knows. Look at our next step. It's saying, oh, if you want to solve for the payback period, what you're going to have to do is you're going to have to take the $9,000 that you paid up front, and you're going to have to divide it by the 1,800, just like we did over here, just like we did over there. It knows. The algebra knows what's going on. I love that. It's like magic. It knows what's going on. So anyway, of course, you get 5 years. 5-year payback period. Cooler than heck. I still think that's a cool graph, man. I mean, you could put I suppose you could put like a puppy on it, or maybe a happy baby out here, or a happy toddler playing around with all the money that he saved or something, just to make it even better. But the businessman is going to be going, yeah, man, I love that crossover point. I love this opening gap. This is awesome. Probably buy your solar panels. So just another example. This one's very similar in structure. It's not exactly the same, but it's very similar in structure. And it's just to make sure we're kind of tracking. The best thing would be for you to just kind of pause this video for a bit and try this problem yourself, see what you get for equations, see what you get for a payback period, see what your graph looks like, and just compare it to mine. Just a quick hint, I would actually set up the axes the same as for the other one. So this is going to be X years going by, and just go 1, 2, 3, 4, call that 5 years, 6, 7, 8, 9, call that 10 years, 11, 12, 13, 14, call that 15 years. And the same thing with the cost here, right? This is going to be Y dollars going up. Go by 2,000 at a time. So 2, 4, 6, 8, that would be 10,000. 12, 14, 16, 18, that would be 20,000. If you label your axes that way, your graph will fit. Let's put it that way. Barely, but it will fit. Okay, you ready to pause? Ready to do it? Ready to try it? Okay, pause. Okay, you're back. Barney wants to decide between an oil furnace or a geothermal heat pump. He's got to heat the place. He lives in like a cold climate, I guess. He needs to heat the place. Could get an oil furnace, nice traditional solution. Could get a geothermal heat pump, nice hip modern solution, although they've been making those for years and years and years and years and years. But anyway, to heat his business. Now the geothermal heat pump which certainly sounds cooler, would actually cost $15,000 to install. But then he'd be looking at, oh, maybe $500 every year to heat the business. Now, that's not a bad heating bill. If you can heat something, what are you doing? What is that? Hey, what is that? I don't know what that was. Anyway, it's not much to pay $500. Well, in this state anyway, to pay $500 to heat your business for a whole winter season. Jeez, that's nice. The oil furnace, on the other hand, is a lot cheaper up front. Only $4,000 installed. They'll probably even call it a high efficiency oil furnace too, just to help you be happy with your decision. But then you'd be looking at maybe $1,200 for a season of heating. So not $500, but $1,200. So that's quite a difference in the per season cost. So we want to make a similar kind of graph. See if we can maybe make a cool brochure or something. So let's see. Part A. Write an equation for dollars spent on heat versus years using geothermal. Geothermal. So you have to look up the numbers for geothermal. 15,000 up front. So that's going to be the intercept. You start at 15,000. $500 per season. That's your slope. You go up 500 every time you take another season. Up 500, march forward one season. Up 500 and so on. So that's your slope. So that's your M. That's your B. And so the cost here is going to be $500 per season plus $15,000. That's your geothermal right there. Incidentally, there's a lot of people, you'll see this a lot. People will write this equation in a slightly different way. They'll say, I'm starting by paying $15,000 and then I have to add $500 for every year. So I have to multiply 500 times the number of years and add that to the 15,000. Now, if you look at this equation and you look at this equation, I hope they look exactly the same to you because they are exactly the same to you. So personally, I don't care which way you write the equation. The first way, the second way, they're both the same to me. So if you like this way better, fine. If you like this way better, fine. It's just something to be aware of, that you'll see it both ways. Part B, write an equation for dollars spent on heat versus years using oil. Using the oil. Okay. So the oil was going to be $4,000 to start. That's our B. $1,200 each season. That's our M. So $1,200 times the number of years, because it's $1,200 every year, adding for $4,000 that you had to pay up front to get started with your oil furnace. And there you go. Or again, you could just as easily be thinking of it this way. First I have to spend $4,000, then I have to spend $1,200 every year. So I have to multiply 1,200 times the number of years. Same equation, just looks different. What do you say we graph the things? So call this equation A, I guess. 500x plus 15,000. So we're starting at a y-intercept of 15,000. Holy cow, turn to it, that's here. That's where we start. Now our slope isn't so bad though. It's only $500 per season, which means one season you're only up 500. After another season, you're up 1,000. After another season, another 500, another 500, another 500. Wow. So you're going up something like this. I suppose you could think of it this way. It's $1,000 every 2 seasons, right? 500 a season means 1,000 every 2 seasons. So if I come forward 2 years, I can go up 1,000. And if I come forward 2 years, I can go up 1,000 again. It's just a little easier to draw it, I think. 2 years up 1,000, 2 years up 1,000, and you just try to keep that going. I guess 1 year 500, 2 years up 1,000. Right. So there's our equation A. Which one was that? That was the geothermal heat pump. A. Let's try to make that look like an A. What do you say? Does it look like an A? Over to the oil furnace now. This will be our equation B with the oil. So our starting point, remember this is your y-intercept, our starting point is only $4,000. That's the big selling attraction, right? Hey, you can get started for only $4,000. Hold on to that other money and use it for something else. You're starting way down there. On the other hand, every single year, you're going to have to pay $1,200 to to heat the place. So $1,200. So 1 year I have to go up, something like $1,200. So remember, from here to here is 2,000. So halfway is 1,000. So 1,200. I'm trying to eyeball it a little bit and say, yeah, it's something like there. Go up another 1,200. Boy, how am I supposed to do this? Another 1,200. Let's see, 4,000 plus 12 plus. Let's see. I'm going to go like this. Sometimes you just got to do it like this. So is that okay? I started at 4,000 at 0 years. After 1 year, I'm at 5,200. After 2 years, I'm at, let's see, add 12 again, 6,400. After 3 years, I'm at 7,600. After 4 years, I'm at 8,800. And after 5 years, I'm after 8,898. Oh, that's cool. I'm at a nice even number finally. So after 5 years, I'll be at a nice even 10,000. So notice I went 5 years over, 3 grid points up. I could take advantage of that by going 5 years over, 3 grid points up. It's nice to take shortcuts like that sometimes. So 1, 2, 3, 4, 5 years over, 3 grid points up. Ooh, almost, almost. Let's get this out of the way. Clear some of this static electricity out of here. So you can connect all the points in between if you want, but I think this is going to be good enough. Just kind of go like this, try to make it nice and straight, and notice, ooh, I don't know where it's crossing. I don't know, it's crossing somewhere around here. I don't know if it's quite there or where it is, but somewhere around 15, 16 years. 15 and a half to 16 years is when the lines cross. Now try to imagine a brochure based on this. Hey man, spend your 15 grand on a heat pump, and then when you get to be an old man, you'll just barely start saving some money. I don't know about you, but I'm not impressed. I am not impressed. I think you're going to have to put some cute puppies on the brochure. Maybe some smiling toddlers, maybe a whole big smiling family with white teeth and the sun shining and everything. I don't think you're going to be able to sell it based on the money. I don't know. That's just me thinking, though. Oh, and then to finish this up, what is the payback period? Solve for the exact value and then show this point on your graph above. Well, we could solve for the exact value a couple different ways, but I'm going to do that standard trick that I showed you at the end of the last page. You say, okay, or this one, heat pump, or not heat pump, geothermal, it is a heat pump, is 500x plus 15,000. That's one of our cost equations. That's the geothermal. And then the oil one, I believe, let me look back again. The oil one was 1200x plus 4,000. Put that right there. That's the oil. When are these the same? This is the crossover point, right? These are the same when. And what we'll be able to do is solve for x. Because we'll be able to say, well, when the cost is 500x plus 15,000 is the same as the cost at 1200x plus 4,000, happens for what value of x? Solve and find out. So I think what I'll do is well, you could do this a couple different ways. Maybe I'll be all disciplined and put x on the left no matter what. So 500 minus 1200 is a negative. 700x plus 15,000 equals a 4,000 over here. And then you say, okay, now I got to subtract the 15,000 on both sides. So I got a negative 700x over here. 4,000 minus 15,000 is a negative 11,000 over here. And you divide both sides by the negative 700. Negative divided by negative is positive. 11,000 divided by 700 is, oh, didn't I do this? Did I do this? I did do this. Rounding a little bit, I got 15.714 years. If you want, you can say 0.714. Notice that kind of means the same thing as 71% of another year. And a year has 12 months. And when I multiplied 0.714 by 12, I got just about 8.5. So you could say it's about 15 years, 8.5 months, which I think makes a better brochure than saying 15.7 years. I don't know. I'm not the advertising person. I'm just saying. So hopefully you got answers like almost exactly the same as mine, and you're digging this, and you're ready to start the homework. That's what I'm hoping. If you have any questions about anything I said or did around here, because every now and then I do say something that's not what I was thinking I said, you can just leave questions right down there in the comments. For now, I'm going to say bye by finding the end